Hello everybody. In this video, we will create a small tutorial for NumPy. What is NumPy, by the way? So NumPy is a fundamental library that is critical for all the machine learning that you'll be doing. So you name any packages, TensorFlow, PyTorch, SciPy, your MATLAB, everything is built upon the foundation of NumPy. So it is kind of important, which is why we all should understand how NumPy works so that you can manipulate all those packages if you understand the rationale behind it and how data operates. So NumPy is basically array of numbers. That's one way to look at it. But what's critical is NumPy is very fast because the reason it's fast because it uses only one data type, which I will go over in a second. It uses only one type of data, which makes this really fast. But if you compare that with list has multiple types of data, which makes it a lot harder to operate because obviously it needs a lot more computing. That's the one of the reason why NumPy is fast. So let's begin with it's simple. So what you have to do is you have to import NumPy as NP. This is the standard practice. One thing I want to make sure you can do this tutorial in google.colab. So maybe I should add that to your this is probably the best place to go, google.colab, where everything is built. The NumPy is already installed. All you have to do is import NumPy. So you just go there and do it and practice with me. Or you can do it like me, like I'm doing right now with Jupyter Notebook. If you want to do, make sure your NumPy is installed. It should be installed when you install the package Jupyter Notebooks. But if not, just go to your command line and do pip install NumPy. So you just do pip install NumPy. That should take care of everything. Okay, let's import our NumPy. So NumPy is basically we are dealing with arrays or matrices. That's one way to look at it. So let's create. I'm just gonna use alphabets because we're gonna be creating so many arrays. Obviously, I'll run out of names and it's easier to type. Okay, so let's start with, let's create an array. So to create an array, simple command numpy.array, and we'll create a list of numbers. So let's keep it simple. There is an easier way to do this, but let's start here. Okay, so this is an array. So let's print A. So you see, this is an array and this array has one dimensions. Well, how do I know? Well, I can see it. If you're dealing with bigger arrays, you can find the dimensions of your arrays by n dimensions. So you can see it has one dimensions. Let's look at the shape. So you can look at the shape of this thing by a.shape. So it has 9 object. So it has 9 numbers. So maybe what can we do? Let's do something easier here. Let's do 7. That way we have 8. So now what I'm going to do is let's reshape this thing. So instead of 1 dimensions, let's make it 2 dimensions, right? So let's reshape this thing. Let's reshape this thing. And we're going to reshape into 2 by 4 matrices. All right. So let's reshape and let's call it B. So B equals to a.reshape. And let's look at our B right now. So what it's going to do, you see, so what it is doing is it's taking our number from here, 0, 1, 2, 3, all the way here, and just splitting into a 2 by 4 matrices. So if you remember, the first digit here represents how many rows. So in this case, we got 2 rows. And in the second one is showing how many columns we have here. Now this will get a little bit more complicated when we deal with higher dimensional arrays. So let's guess how many dimension this one has. Well, obviously we can see here it has rows and it has columns, so it has 2 dimensions. Well, we can confirm that by b dot dimensions, and we got 2. And you can easily find the shape as well. Okay, I shouldn't have done that. Control Command Z. Okay, so we can find the shape of this thing by b dot shape. All right, so that's our shape is 2 by 4. All right, so let's make it a little bit more complicated this time. Remember I said we could do this in a better way instead of typing everything. So let's do it a better way. Let's create a matrix C equals to np dot arrange. And I want to get all the numbers up to 24. And so let's see, print C. Okay, so you see we have all the digits up to 24, or so it has 24 digits. Now let's pay attention here. So in programming, we have, this is our index 0. Index 0 is always the first number. Index 1 is always the second number. And index 2 is the third number. So obviously the index 23 will be the 24th number. So let's convert into a matrix, something like reshape. Let's say let's reshape it 8. Maybe we can create something 4/6. When you do this, so if you see we have 24 numbers here, and when you do that, it's gonna change, it's gonna reshape to 4/6. So the number has to match. So let's say if I put here 2/3, so let's say I put 2/6, then 2 times 6 is 12 number, but we got 24 numbers, so it won't be able to convert. Okay, so make sure it matches. So that's why I was a little bit critical. So let's put 4/6 and let's print it out 6. So now we have a matrix right there. Okay, let's try to access all the numbers here. Let's try to understand all this indexing right here. So so this one here is your first row and first column. This one here is first row and third column. This one here, first row and sixth column, right? So what's the index for the first one? Index for first, anything in the first in programming, index number is 0. So you can access all those numbers. So let's say print. I want to access certain number. So let's say I want to access 15 here. Can you index it? Pause the video here and try yourself. So 15 is on the third row. So which means third row means second index. 15 here is on the fourth column. So fourth row means it's gonna be under your third index. And voila, we got our 15. So you can change each one of this number any way you want. So let's say I wanna change that 15 number to 69. So let's say I wanna change that same number to 69, and we will preprint our array. So you see that same number 15 is gone. Now it's 69. So we could do the same thing. Let's say we want to change C0 C00 to make it 420. Oh, 320. Let's make it 420. Why not? All right, so let's reprint it, and you got our first digit becomes 420. Okay, next thing that you want to be careful about is, let's say you want to print everything on the first row. So let's say you want to print everything in our first row. So how would you do this? So you can access to the first row, so print C. So you can access everything on the first row by putting this word. So you are getting everything on the first row, which means index is 0. And then you want every column, right? So when you want every column, all you have to do is put colon sign there. So that would print everything on the first rows. You don't have to do this. If you just put 0 in there, it will do the same thing as well. But that's kind of the easier way. So let's say you want to print everything on the last column here. So how would you do this? So pause the video here for a second. So you want to print, or you want to see everything in the last column. So how would you do this? So the way we can do this, so okay, these exercises are just enough to get you around the indexing so that you can understand your data a lot better. So this means you want to print every row here in the last column. So which means I'm gonna put colon on my row side, and I want everything on my last column. So what index would that be? So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5th index. So voila, so we got print everything 5, 11, 17, 23. There is another way to do this. You can do this -1. So -1 is telling us, this is telling us you just want the anything from the last there. If you want this 4, 10, 16, 22, then you do -2. So it's counting from the last. All right, so that's all we had. Okay, now I want you to get another indexing problem. Let's say you want to print all of these, like you want to print all the way 6 up to 23. How would you do this? Pause it and you can solve it, and then we can check. Okay, so I want to print everything from here. So let's access those. Print C. Let's index them. So you want to print all the rows here after the 0. So first row is 0. So you can do this something called 1 this. So this will print everything from the first index, including the first index. So you see it included the first index here, 6, and then it printed out from there. Let's say you want to print everything until here. So let's say you want to print the first, second index. Maybe let's include, okay, let's include these two. So let's say you want to just print out everything up to here. So how can we do that? Well, we can do that. So print C. Okay, so now you are starting from the beginning. So you want to print everything from the beginning, but up to here, right? So which means you gotta pass the index 2 here. So I will explain in a second. So when you do this, this means when the number is on the right side of the column, this means it's not gonna include second index, or in this case, the index number 3, but it's gonna include everything before that. So this is 0, this is 1, this is 2, index number 2. So this means it's not gonna include 2 because we wanted to print it out only this much, right? So that's all we had here. And there we go. So we had printed out our first 2 rows. So you can do the same thing for column as well. Okay, the reason I put this 24 shape because I want to explain something more. What if we have higher dimensional arrays? So let's say I want to create a new matrices from here. So I want to create a new matrices. Let's call this D and np.arrange. And we have 24. And then we're going to reshape. And we're going to reshape this time to a higher dimensional arrays. Now this is important because you will be dealing with these higher dimensional arrays. Let's try to understand. So how, when you print this higher dimensional arrays, how it's represented. So let's look at the last axis. So in this case, the last axis, the number 4 is printed as column wise. So you can see here we got 4 columns. And then the next axis, which is 3, So this is the last axis, then the one before is in the row. So we got 3 rows. And the first axis is written, so how many sets of data you got? Well, you got 2 of this, right? So you see this big chunk there. So those are the rows. So you got 2 big rows, and that's the first axis. And then 3. So then you got 3 another rows in each one of those. And then we got 4, and then we got 4 columns. So it gets really complicated to wrap our head around. So let's say you want to get access to number 5, okay? Maybe let's get access to number 17. How would you do this? Let's pause the video. Let's see. So we want to access the number. Okay, the question is, how would you get to number 18? The purpose of this whole exercise is to understand your data. Okay, so what each number means and where it is coming from. Okay, so let's say you have here 18. So where exactly the 18 is? The 18 is on the second big rows, right? So in this set of data. So our first, on the first dimensions, the number would be 1. Oh, no, not there. Here it is on this row. So the first row is 0. This row is 1. So that's 1. And then within this here, where exactly it is on the 0, 1, 2. So it's again in the middle, 1. And within this here, where exactly it is, so this is 0, 1, and 2. So, and voila, we got our 18. So that's how you can access and understand all the data. Okay, one thing I mentioned in the beginning is why NumPy, why we use NumPy. The reason we use NumPy is because it is fast, right? So I'm just gonna print one of my earlier matrix. So you see print B, we got 0, 1, 2, 3, 4, 5, 6, 7. It's a 2 by 4 matrix. You can see the data type. Here it says int 64. So this means all of the data here are int 64. I will create a new video later to explain what's the difference between int32, int64s, and int16s. So the beauty of NumPy is it creates all those arrays, and where all the elements of these arrays have the exact same data type, which makes it really nice to calculate and make things easier. Okay, so these are int64s. What if you don't want int64? Let's say you want int32. Well, that's pretty easy to do. Let's create a new array. So we are up to alphabet 2D. So let's create a new arrays. So let's say e equals to np.array or np.arrange. Let's say we want to go up to 7. And we want to reshape. Okay, maybe let's keep it smaller than p.array. And we want to change 1, 2, 3, 4, 5. Let's keep it one dimensional, 6. And let's create a data type. So you can create the data type here as int 16. So which means it's going to be using int 16. So you print e. So we got an array, one dimensional arrays. You can check the data type. Data type is int 16s. You can change the type later as well. Let's say you want to change to int32. So you can do e.s type and pass int32. So that would change. So now the things is changed. So now it becomes int32. All right. So that's all about the data type. So that's why NumPy is faster. Okay, let's try to do mathematical operations on each one of them. So let's say, let's reshape this again. F equals to E dot reshape. And let's create a 2 by 4 matrices, 2 by 4 arrays, and print F. Oh no, what did I do? Oh, because, oh, I see. So our E had 6 element, and I tried to reshape with 2 by 4. 6 is not 2 by 4, right? So it has to be 2 by 3. All right, there we go. So now we reshaped into 2 by 3. All right, so let's, we have a reshape, and let's create a matrix. So you can do all sorts of algebra. That's the whole idea of it. So let's say you create a new matrices where I'm gonna take F and add 10 to every element. So we are creating a new matrix, new array, we are creating a new array G. And how we are creating, we are taking F, which is here, and we are adding 10, which is a scalar quantity, to every number. You can do this, and you notice our first element, it becomes 1 plus 10, 11. And the second element becomes 2 plus 10. So you can do all sorts of mathematical operations. So you can do, let's do another one. So we are creating a new arrays, and how we are creating it, we gonna take G here, and then we're gonna multiply 3 to each numbers. Okay, so let's print it out, H, and there we go. So we print it out. So it takes 11 and multiply with 3. So take 11 times 3 is 33. 14 times 3 is 42. So it's multiply every single number. Again, there is another operation. So if you know a little bit of linear algebra, there is matrix multiplications, which is different than simple scalar multiplication. So matrix multiplications is what you have to make sure is your so you can, okay, I'm gonna write this matrix matmul. Okay, let me write this. Okay, so you see here, if you're multiplying two matrices, the first matrices, not matrices. So the first matrices, the first matrix should have the same number of column as the number of rows in the second one. If you flip the order of this matrix multiplication, it's not going to work. So let me repeat again. So this is linear algebra recap. So number of column here should match the number of rows here. And your answer will have a 2 by 4 matrix. So you notice here, your number of columns here must match with the number of rows here, and the answer is going to be the same number of rows of your first matrix and same number of columns with your last matrix. Okay, so if I want to multiply something with this, I need something that is 3 by 4. So let's create a something another matrix H with a 3 by 4 data. So let's say, okay, we are onto the H. Let's create something new. I is gonna be equals to, let's say, NP dot arrange, and let's say we want up to 12, and then reshape it, and we will reshape it to 3 by 4. Okay, so what I'm doing is I'm intended to multiply this matrix 2 by 3 with something that is 3 by 4. Okay, so we can check print dot, let's check the matrix first. Okay, so this is our 3 by 4 matrices. So now let's do matrix multiplication. So this is after matrix multiplication, this number is, it's gonna be so let's create a matrix np dot, so there is a function called matmul, matrix multiplications. And what are the numbers you are multiplying? You're multiplying with the we are multiplying h with I. Okay, so we just write h and I, and let's print it out. Print after mat multiplication. And just like we said, what should be the shape of this thing? The shape of this thing should be 2 by 4. Let's check it out. And you see it has the shape of 2 by 4s. All right, so that's about, you can create all sorts of matrices. Like for example, let's create something, test. Okay, I'm gonna call it test 0. You can create matrices just like this, np.zeros. So what it's gonna do, it's gonna create a arrays with a bunch of zeros. Now let's pass this number. Let's say I want 2 rows and 4 columns here. And let's see, print test 0 right there. So it's zeros. So can you say what is the type of data here? Data type, you can check the data type here. It's float because you see a decimal. Let's convert that into int 32. D type equals to int 32. I will create a video to explain again difference between int32 and 64 and 16s. Okay, so now we got, if you do this again, we got int32. Okay, so that's 2 by 4s. So let's say I want to create another one, test1. And this time I'm gonna be creating ones. And I'm gonna create 2 by 4 again. I'm doing this for a reason. I will explain. And I want my data type to int32 as well. And let's print our test1. Okay, what this will do is it will create an array with just ones. Okay, so we got 2 arrays, test0 and test1. They are both made up of 0 and 1. Okay, the reason I was saying this is, what if you want to combine 2 different arrays? That's one thing we always do in a lot of machine learning projects where you want to combine arrays or split arrays. So what if you want to combine this arrays and this arrays? Well, there is one thing you can do. Let's say combined arrays equals to np dot append. So now you just want to pass the array that you want to combine, test0, and I want to combine test1. And then again, that is you don't have to use append. There is a bunch of other functions you can do as well. So now here is the tricky part. So so try to imagine what this will do. Let's say print. Okay, before I print it out, so try to imagine what you're doing. So we are combining test0 and test1 in the axis 0. So 0 means your first index, or if you look at the data type, what is the first one is? It's your row. So it's gonna be adding the rows. So it took the first one and then matches with the rows and added the next one. It did it because everybody has the same number of columns. What would happen if I put this 1? It will combine across the columns. So you see it's there. So make sure it's by default 0, but if you want to combine column wise, like to stack side by side, you gotta make sure you put the axis equals to 1. So that's by saying axis equals to 1, that means you are saying combine them in the second dimensions. That's the proper way to think about it, because imagine if you have multiple dimensions. When you are saying axis 1, that means combine them in the second dimensions. If the axis is 0, that means you are saying combine them across the first dimensions. If you're dealing with 3-dimensional, 4-dimensional, you can combine on any dimensions you want. So which is kind of pretty nice. Let me see what else I'm missing. Yeah, I'll do one last. You can create another fake arrays. I'm running out of names here. Let's say you want to create another fake arrays. So let's call it np.full. This is something interesting. So what this will do is it'll create an array with just one type of numbers. So these are kind of handy if you are if you want to work, these functions are handy if you want to just create arrays for some particular purposes. np.full, this wanna give. So you wanna pass a shape. So let's say the shape is, I'm gonna put 2 by 3 by 5. So this is a 3-dimensional array. So try to visualize how this will look. Okay, and another thing that you want to pass is what number you want to pack. I want to pack my arrays with 69. Okay, so let's print our fake arrays. All right, so we created a 2 by 3 by 5 3-dimensional arrays with just the number 69. You could pack the number any way you want. So let's try to finalize. Let's see if we remember everything. Understanding dimension is important in when you're dealing with arrays. So that's like, if there is one thing you want to learn from NumPy is it's all about dimensions, because that's gonna be the important factors. Okay, so the fifth means on the last, so we got 5 columns here. 3 means each one of them has 3 rows, and 2 means we got 2 groups of data. So it's a multi-dimensional, 3-dimensional setup. All right, so this is all about beginner's tutorial for NumPy. I will create another tutorial that's gonna contain a lot more advanced stuff. Again, it's practice around on Google Colab. I will have this file for you in the GitHub page, so you can just check the numbers. Ignore the names. Okay. All right, so let's stop here.